In 2023, two strange meteorites were discovered in the Sahara Desert. Together, they weigh about 3 pounds or 1.4 kilograms. And while we don't know exactly what they're made of yet, researchers suspect they may have come from the solar system's innermost rocky planet, Mercury. If confirmed, these finds would be the first pieces of Mercury ever found on Earth, and scientists are pretty sure there are more like them waiting to be found. What makes Mercury so hard to study? How do we know if these meteorites really came from the planet? And that's where the two meteorites found in the Sahara come into play. Fragments like these typically originate as part of a larger object, but get knocked off by a collision with another object in space. Some astronomers think that Mercury is regularly bombarded by pieces of rock kicked up from the sun. A postdoctoral researcher in achondrite meteorites at the UK's Open University and lead author of a study on the Sahara meteorites published in June in the journal Icarus. The biggest is that the fragments appear to have formed about 500 million years earlier than the surface of Mercury itself. However, Ryder Stokes said he thinks this finding could be based on inaccurate estimates, making a conclusive assessment unlikely. The previous best candidate, based on the level of interest it piqued in astronomers, was a fragment called Northwest Africa NWA 7325, which was reportedly found in southern Morocco in early 2012. Ryder Stokes said that was the first meteorite to be potentially associated with Mercury. They are about 4.5 billion years old, Ryder Stokes said, and most of Mercury's surface is only about 4 billion years old. So there's a 500 million year difference. However, he said he thinks this discrepancy is not sufficient to rule out a Mercurian origin, due to the limited reliability of MESSENGER's data, which has been also used to estimate the age of Mercury's surface layer. It got a lot of attention. A lot of people got very excited about it. It doesn't mean that these samples aren't good analogs for regional areas on the surface of Mercury, or the early Mercurian crust that is not visible on the modern surface of Mercury. Further analysis, however, showed a richness in chrome at odds with Mercury's predicted surface composition, may be able to answer long-standing questions about the planet, such as where it formed, and whether it has any water, and that it took precise matching of their chemistry with data about the surface of Mars, taken by the Viking probes to convince researchers to take a closer look. The history of internal melting of the body and clues to planet formation, and early solar system processes. Lunar meteorites were also not broadly acknowledged to be in meteorite collections until after the existence of Martian meteorites had been demonstrated in the 1980s, he added. Even though the Apollo and Luna missions had returned abundant samples of lunar materials more than a decade earlier, until we return material from Mercury or visit the surface, he said, it will be very difficult to confidently prove and disprove a Mercurian origin for these samples. And identifying fragments of Mercury would be especially crucial, since a mission to gather samples from the planet closest to the Sun and bring them back would be extremely challenging and expensive. I'm going to discuss my findings with other academics across the world, he said. At the moment, we can't definitively prove that these aren't from Mercury. So until that can be done, I think these samples will remain a major topic of debate across the planetary science community. However, these meteorites lack a chemical compatibility with what astronomers know about the planet and the presence of sulfur-rich minerals, he added. These chemical traits have been interpreted to indicate that Mercury formed from precursor materials much more chemically reduced than those that formed Earth and the other inner planets. It may be that remnants of Mercury precursor materials still remain among meteorite parent bodies somewhere in the inner solar system. So the possibility that these two meteorites sample such materials warrants additional study. Solomon, an adjunct senior research scientist at Columbia University in New York City, was not involved with the study, but he said he thinks the samples still hold research value. Ryder Stokes said, that's what's so exciting about the samples that we studied. They have sort of the perfect chemistry to be representative of Mercury, he said. However, Mercury is a lot closer to the Sun, so anything that's ejected off Mercury also has to escape the Sun's gravity to get to us. It is dynamically possible, just a lot harder. No one has confidently identified a meteorite from Mercury as of yet, he said. Others think that Mercury occasionally collides with pieces of debris left over from the formation of the solar system, a time when our neighborhood of space was filled with smaller rocks and dust. Either way, the fragments blasted off Mercury's surface could eventually end up on Earth. Both meteorites from the study, which Ryder-Stokes analyzed with several instruments including an electron microscope, contain olivine and pyroxene, two iron-poor minerals confirmed by Messenger to be present on Mercury. They also contained only trace amounts of plagioclase, a mineral believed to dominate Mercury's surface. And what would knowing Mercury's composition tell us about our solar system's origins? It's so close to the Sun that it whips around our star in just 88 days. Each time an object strikes the surface of either of those planets, the impact blasts a piece of crust into space. Eventually, gravity pulls the fragments back down to the surface of the home planet or another nearby planet. Although not every planet will eject fragments Earthward during a collision. Venus is closer to us than Mars is, but its greater gravitational pull and thick atmosphere probably prevent the launch of impact debris. But some astronomers believe that Mercury should be capable of generating meteors, and because it has no substantial atmosphere, it experiences wild temperature swings between day and night. All of those extreme conditions make Mercury a difficult target for exploration. Here's what we know so far. Mercury is the smallest and innermost rocky planet in the solar system, and yet scientists want to learn more about the planet because it can help us better understand how the solar system formed. So far, we've only managed to send two uncrewed spacecraft to visit it, Mariner 10 in 1973 and Messenger in 2004, to avoid getting incinerated. The first option for reaching Mercury is to launch when conditions are ideal, usually once a year around this time of year. Then the spacecraft takes advantage of the alignment between Earth and Mercury by essentially surfing on our planet as momentum. But it's a slow process. Mariner 10 and BP Colombo took nearly 7 years to reach Mercury, and that meant that these spacecraft had to be launched with a limited amount of fuel and designed to survive on their own power source for at least 7 years in Mercury orbit. This means that there hasn't been enough room or power to bring back any samples from the planet for scientists to study directly, neither of which orbited the planet, but both of which returned the first close-up views of the planet's cratered, heavily scarred surface. The third, BP Colombo, is currently on its way and due to enter Mercury orbit in late 2026. One reason Mercury has been so hard to explore is that it is so close to the Sun that any spacecraft headed there needs to conserve fuel. But scientists think they can get an idea of what Mercury is like by studying fragments that have crash-landed on Earth. Meteorites are bits of larger objects like asteroids, comets, or planets that break off and land on Earth. Of the known meteorites that have hit our planet, more than 1,100 have come from the Moon and Mars. Based on the amount of lunar and Martian meteorites, we should have around 10 Mercury meteorites, according to dynamical modeling, said Ben Ryder-Stokes, and his co-authors are the first to warn of some inconsistencies in matching those space rocks to what scientists know about Mercury. But there are some compositional clues that suggest the meteorites might have a link to the planet closest to the Sun. It's not the first time that known meteorites have been associated with Mercury. More recently, astronomers have suggested that a class of meteorites called aubrites, from a small meteorite that landed in 1836 in Aubris, France, might come from Mercury's mantle, the layer below the surface. Most of what is known about Mercury's surface and composition comes from NASA's Messenger probe, which assessed the makeup of the planet's crust from orbit. The biggest point of uncertainty, though, is still the meteorite's age. These estimates are based on impact cratering models and not absolute age dating, and therefore may not be entirely accurate, Ryder-Stokes said. With more modern instruments now available, BP Colombo, the European Space Agency probe, that will start studying Mercury in early 2027. Having material confirmed to have come from other planetary bodies helps astronomers understand the nature of the early solar system as building blocks. Clues to planet formation. Sean Solomon, principal investigator for NASA's Messenger mission to Mercury, said in an email that he believes the two meteorites described in the recent paper likely did not originate from Mercury. The primary reason Solomon cited for his doubts is that the meteorites formed much earlier than the best estimates for the ages of rocks now on Mercury's surface. Nonetheless, The two meteorites share many geochemical characteristics with Mercury's surface materials, including little to no iron. Solomon also noted that it was difficult to persuade the planetary science community that there were samples from Martian meteorite collections. Once samples are confirmed to be from a planetary body, Solomon said they can provide crucial information not available from remote sensing by an orbiting spacecraft on the timing of key geological processes. Ryder Stokes plans to continue the discussion around these meteorites at the annual meeting of the Meteoritical Society, which takes place in Perth this week. As for the meteorites themselves, they will continue to sit in a lab at the Open University.